Welcome back. This is the first in a series of videos I intend to do on the hanging idle, high idle, poor idle, mainly the hanging and high, but different things with poor idle. When someone tries to fix it, a lot of times it creates the hanging idle. So I want to go through a little bit on that, how it compares to other platforms that someone might have used. The first thing I'm going to do here is cover on the master upload sensor and how it's related. A little bit on troubleshooting it, and different things that I know of. As far as the tuning part, what can be adjusted through tuning, which you have to be careful with because you can turn the hanging idle into stalling real easy, so you have to be aware of what's going on there. Dashpot preposition. Uh, this is the same with Holly if I would be the whole position. And then we have the dashpot decay rate. That's where it tapers down when it feels that it's time to do that. Increasing these values will cause it to decay quicker. Lowering them will soften it and bring it down more slowly. Might have seen had one that goes high when it's in drive or moving above 4 or 5 miles per hour. When you come to a stop, it comes back down. With those tables they're different. The drive table and the neutral table will be different. With Holly, you have the IAC hold position, that's the same as pre-position. These others will act a lot like the dashpot decay. Idle speed control neutral. The amount of air that's carried through these, that's an offset. That's an offset to the IAC. It can't physically change the numbers in the software. It can't physically change the IAC valve. So this is actually offsetting it. The cars with big cams are probably gonna need to add some air to some of these, but it has to be done at RPM levels so it doesn't create the hanging idle. See, this 600 RPMs, you got 0.49 in neutral, and about 600 RPMs, you got 0.66 in drive, so that's enough to kick the idle up. So a lot of times these numbers can be just brought down, and that stops that part. I'm going to cover some other stuff in here that's not necessarily related, but probably good for somebody to see. Master airflow sensor, get it down where I can see. But that's the curve. It's normally a 30-point curve. These are the positions, TPS, actually the master airflow flow rates. These numbers can be raised or lowered to add fuel or take away fuel. These can become, the numbers don't change, but the master airflow sensor's signal that it sends can become offset. We can add 10% too much fuel. It can be broken, fragmented into the higher values where it acts like a rev limiter. It just stops the fuel. You've got higher numbers here, and then all of a sudden it's got a zero, or the same effect. If you've ever wondered what's really happening when you unplug the master airflow sensor, it's reverting to this alpha N table. What it does when you unplug it is whether it runs better or worse. It just depends on how well it likes this table. It's nothing. It doesn't really tell you much of anything, so don't recommend that. Sure don't recommend unplugging any electronic device that's wired straight into the vehicle's computer while it's running, while it's powered up. If you're going to do it, shut it off, turn the key off. then do it. Really, there's just no reason for it. This particular calibration here is 2004 Mach 1. It's the same all the way back to the Guff 1, Guff B, Foxbody. All this will be the same. The master airflow sensor does nothing when you're cranking. It doesn't come into play until the engine's actually running. Uh, Cranking fuel is here. It's not. There's not enough airflow through the master airflow sensor to get a reading on that. And these tables can be turned. You can unplug the master airflow sensor, start the engine, tune these tables, and make it run pretty good. Although alpha N is TPS versus RPM is not the best. Mainly find it on a lot of track cars, really high horsepower stuff. I mean, there's a lot of stuff you can do here. Where's the processor? I'll move over to the wiring diagram. This particular one is 95 GTR Cobra, 4-wire map, 6-wire is the same, other than it's just got the addition of IAT sensor. Of course, we need to verify we got the full battery voltage on that pin. We need a good ground on the other pin. We need 5-volt reference here, and this signal wire. And before you do this, do your homework and make sure you know what the pins are. If you don't feel comfortable doing it, don't, because it can blow the computer. We would pierce this reference cable and come across to the return. And at idle, we should see about 1 volt. When you turn the throttle by hand, it should climb, and it should fall. When you release it, should fall immediately back down to the idle voltage. If it doesn't, then there's either something internal on the printed circuit board, or more likely corrosion in this return, causing resistance. It's putting a latency and delay into the signal wire that's acting a lot like a draw through or blow through with boost with turbos or superchargers. With the turbo, the blades keep spinning. It's a lot like it. It will cause you hanging idle for at least several seconds, because there's 6, 7, 8 liters of air that's already passed it's in the plenum and intake tube, and until that burns off, and it's still getting that extra fuel, until it burns off and goes lean, the idle's not going to come down. Like say you use caution, it can fry the computer if you short something to ground or 12 volts back through the signal. These boards burn out sometime and do that in themselves. They fry the computer. I know that happening on one, and the fellow didn't know what had happened. He had the computer rebuilt, and he didn't check his pins before putting it back in, so he hit the key. It blew that computer too. That's ground 10.3. This 10 gauge black cable would have been crimped into the factory negative terminal. When those get cut off and replaced, you really shouldn't use that emergency top terminal. It should be a good terminal with a solid crimp or set screw. And that cable should come over to the radiator core support and go through a ring terminal there, and then it'll go down beside the battery toward the strut tower. It's a little bit shorter on the Foxbody than the SNs, but the same thing. That's the sensor ground. It's used by CCRM. The EEC mass airflow sensor if that ground's bad, it usually shows up first, that mass airflow. It'll send it into the, it'll trigger the limp mode, which is failed math table. So you use a lot of caution with that. Like say if you move battery to the trunk or something, recreate exactly the way they had it, or that's going to cause you math problems. It may kick the idle up and surge and back down, and a lot of things. There's no need to create that problem. Then I'm using Foxbody A9L. That's the math curve again I showed earlier. It's usually going to idle like here, maybe here and here too. Roughly 1 volt. And we do have a couple of PIDs here that can be tweaked. Those can help that overrun of air that you get with superchargers and turbos. Blades keep spinning on turbos even though you've lifted. Got that one, and another one's basically the same. You can work back and forth between those with different numbers and see if it can help. And that's all I have for today. Try to get the next one together right away and go a little deeper into this. There's so many things that cause this hanging idle, high idle. It's not possible to give you one answer. All I can do is hope to teach somebody how to eliminate some of these things and locate it. Thanks for watching.